Hello everybody, it's Area of Regular Polygons, day 3. So today we are actually not going to find the area of regular polygons, but we are going to solve the right triangles in the regular polygons. So what this is going to look like today is we'll have a regular polygon that has just one measurement and it's not a special right triangle. Okay, so on Thursday you did the special right triangles, and the only polygons that works for are equilateral triangles, squares, and hexagons. So we're going to talk about how you can find what you need in order to do it for other polygons. So let's go up here and take a look at the instructions. So it says we are going to solve for the right triangles and regular polygons. Being able to solve these right triangles will be the key to find the area of a regular polygon tomorrow. The three sides of the right triangle are the apothem, the radius, and half of the side length. So let's take a look at this regular polygon again. It says use the key below to solve each part of the regular polygon and right triangle. And then we've got, you can see here, you've got your all of the side lengths that are important in regular polygons and the angles that are important in regular polygons. So number 1 says draw a right triangle that corresponds to the regular polygon, label the diagram with the variables listed above, and solve for each variable. Alright, so first I want to go back to this. The three sides of a right triangle are the apothem, radius, and half of the side length. And we're talking about half of the polygon side. So let's go down here and look at this right triangle. So this right triangle has an apothem as a side length. Okay, the radius, remember that goes from the center to a vertex. The apothem was from the center perpendicular to the side. And then half of a side. And that makes the right triangle. So what we want to do over here is we want to copy that right triangle. And then we're going to label our diagram with everything that it was listed in the key. So A is the apothem. And in this case, A is equal to 8 because that is the given part. R is the radius. And we're going to label both the regular polygon and the right triangle because I want you to see how they correspond. S is the side length, so we can choose any side and call it the side length. I wouldn't name the one down by the right triangle just so that you are not confusing yourself. And then X is half of the side length. So this is X here, and see if I can squeeze in a little X there. All right. Then it says theta is, if we go back to our angles, it says that theta is the central angle and alpha is half of that central angle. So remember, a central angle is the angle between two radii, two consecutive radii. So this is theta. And then alpha is half of that. So it is the angle that is between a radius and the apothem. So here's alpha. And we can't forget our right angle. Okay, so what we're going to work on today is focusing on this triangle right here and solving for it so that we can solve for all of those variables. Okay, so this should look familiar from the right triangles unit. We can start with, let's say we know the apothem is 8. Let's see if I have any space down here. Oh, I have lots of space. So let's make a list of all of our variables and for our answers. So the apothem is 8. We need to find our radius. We need to find our whole side length, and we need to find half of our side length. And then we need to find theta, which is a central angle, and we need to solve for alpha, which is the angle in our right triangle. All right, so let's start with the angles because we have already done that. We know that theta, a central angle, must be 360 degrees divided by the number of central angles. If there's 5 sides, there's 5 central angles. So 360 degrees divided by 5 is 72. So theta is equal to 72 degrees. We know that alpha is half of that. So half of 72 is 36 degrees. And that means that this angle alpha up here is 36 degrees. So this should look familiar. We have a right triangle with an angle on one side and we're trying to find the other two sides. So we're going to use right triangle trig to solve for these parts. So let's focus on the radius r. So for r, if we look at this angle, this 36-degree angle here, we have 8, which is the adjacent, and r, which is the hypotenuse, which means that we're going to use cosine to solve for r. So the cosine of 36 degrees is equal to 8 over r. And then if we put this, let's see here, the cosine of 36 degrees to 4 decimal places is 0.8090. And that's equal to 8 over r. And remember, we're going to solve a proportion, so we're going to put this over 1 and cross multiply. So 8 is equal to 0.8090 times r. So we're going to divide 8 by 0.8090 and get that r is equal to, we'll round to the nearest, we're actually going to round to the nearest hundredth because that's what you're asked to do in your homework, 9.89. And I know that's different than what we did in class. So, okay, so r is equal to 9.89. Okay. All right, so then we need to solve for x. Okay, so r was equal to 9.89. And to solve for x in our right triangle, we could just use Pythagorean theorem because we have 3 of our sides. So let's see if we can scroll down a little bit. So r was equal to, so for x we've got the apothem, which was 8. Squared plus, we're solving for x, squared was equal to our radius, 9.89 squared. And when we solve for x, we've got, let's see here, we get x squared is equal to 33.8121. And so when you take the square root of that, x is equal to about 5.81. And if x is equal to 5.81, remember it's half of a side length, so the side length is just 5.81 times 2, which is 11.62. And there we go. We solved for all of the parts that we were asked for in using the regular polygon and right triangles. Okay, so that's everything that we need. All right, let's do one more. I'll probably go through this one a little bit quicker. Okay, so it's the same instructions. We need to label everything and then solve for each thing that we labeled. So on this one, we're given a side length, and we need to go ahead and draw the right triangle. So we're going to start with our center. Our apothem goes from the center and is perpendicular to the side, so we'll call that A. Our radius goes from the center to a vertex. X is half of the side length, and then the whole side length is equal to 3. That's our given. A central angle, we can do any central angle, but just so that you're staying away from your right triangle, we can just maybe choose one of these for the central angle. We're going to call that theta, and then we let alpha be our angle in our right triangle. So now we need to copy our right triangle off to the side. And we'll label everything. Okay, and we need to go ahead and solve for all of these parts. So let's make our list. So we've got our apothem, our radius, our side length, and half of our side length, which is the side of our triangle. We've got theta, the central angle, and alpha, the angle between the apothem and the radius. So to find the central angle, we take 360 divided by the number of sides. In this case, we have I think it's a septagon, 1, 2, 3, 4, 5, 6, 7 sides. And 360 divided by 7 to the nearest hundredth is 51.4 degrees. And if we divide that by 2 to get alpha, we get 25.7 degrees. And so we're going to round these to the nearest tenth. So this is 25.7 degrees. Okay, so we were given a side length. So we know that our side length is 3, which makes the easy part solving for x, which is half of 3, which is 1.5. And now we're ready to solve for either the the apothem or the radius. And I'm going to go for the apothem first. So if I've got this angle, x is the opposite, the apothem is the adjacent, I'm going to use the tangent ratio. So the tangent of 25.7 equals the opposite 1.5 over a, the adjacent. The tangent of 25.7 is 0.4813. And if we put that all over 1 so we can cross multiply, we get A is equal to, so 1.5 divided by 0.4813, A is equal to 3.12. And then for the radius, it's up to you. You can use a trig ratio if you want to solve for the radius, or you can use the Pythagorean theorem. So let's just go ahead and do a trig ratio. So we've got the opposite, and that's the hypotenuse. So the sine of 25.7 equals 1.5 over r. The sine of 25.7 is 0.4337. Put that over 1 is equal to 1.5 over r. Again, we're going to have to do 1.5 divided by 0.4337. And we get r is equal to 3.46. Okay, and that's it. We have solved the right triangle needed for this regular polygon. So tomorrow we'll put this all together, and then we'll take the last step, which is finding the area of the polygon. So today is the hard work, and then tomorrow we'll do this process again, and then just finish the problem. So pay close attention to the instructions on your homework. Have a great day. Bye.